Let's continue talking about systems of equations. And if you noticed, as you're filling out the notes, or if you looked at the vocab slide here, we still have two spaces left, no solutions and infinite solutions. What does that mean for a system of equations? Well, first it's good to review what is a system of equations. It is two or more equations. Remember, we could have more than two. In our case, we have two with the same variables. So in our case, x and y. And the hope is that we would be able to solve these systems of linear equations by graphing. And we did that. We graphed, we found their intersection, which is a coordinate, and we plugged that back into check. Well, let's talk about some special cases that you may run into while solving systems of equations. Here we have two equations, so it's a system. They have two variables and they share them both. Same variables, two equations, two unknowns, two variables. So this is a system. So let's plot these both. We have y equals 1/2 x plus 3. So up 1 over 2, up 1 over 2. Again, take a minute to pause and to practice your graphing. It's always good to do that and make sure that you are up to speed on graphing, especially from slope-intercept form. Let's connect these dots. And now let's plot red equation. Red equation, y equals 1/2 x minus 1. So 1/2. So that means up 1 over 2, up 1 over 2, up 1 over 2, and so on and so on. All right, now what do you notice about these two graphs, about their slopes? You should notice something. Both the slopes, if you look at the equations, they're both 1/2. And what do you remember about equations that have the same slope? You can tell by looking at the graph. They are parallel. They are parallel. Will these graphs ever touch? They will never touch. If we zoomed out to infinity, they would never touch. And what's neat about that is, with special cases with parallel lines, is they actually don't have any solutions. Think about it. If they never intersect, if they're parallel and never touch, if they never intersect, then there is no coordinate, there's no x and y value that makes them both true at the same time. So parallel lines don't intersect. That is a situation where we have no solutions. No solutions. My spelling is failing me. All right, now let's look at another case. Here's another special case. We have two equations, again, in standard form. So let's convert them into slope-intercept. Subtract 2x from both sides. I'll have 3y equals negative 2x plus 6, and divide by 3. Remember, divide all pieces by 3 by that coefficient on y. So y equals negative 2/3 x plus 2. So let's plot that. 2 and then negative 2/3. So down 2 over 3, down 2 over 3, down 2 over 3. And while I'm plotting this, and while you're plotting it along in your notes, I want you to see if you can see something similar between these two graphs that we're about to look at. All right, let's solve the other one now. And see if you can figure out when you see what's going on here. So let's subtract 4x from both sides. All right, we have 6y equals negative 4x plus 12. What do we need to do? Right, divide every piece by 6. Divide every piece by 6. That'll simplify. Well, so y equals, what's negative 4 over 6? That reduces to negative 2/3 x plus 2. What do you notice about these two equations? They turn out that they are exactly the same. So what can you expect from the solution? What do you think the line of this one will look like? Well, it's going to be the same exact line. It's going to fall right on top of that blue one. So they are in fact the same line, which means that this is a situation where we have infinite solutions. Infinite solutions. These lines coincide. When they coincide, every single point is an intersection. Forever, because lines go on to infinity in every direction, right? And I'll draw those on now. These lines both go on forever. So there will be infinite solutions. Now we've run into this before when we've solved certain equations, fractional equations. But this is another element of that where it's a system of equations. So what is the situation where we have no solutions? Well, that would be parallel lines. You can remember that because they never touch. It's not an intersection. They'll never have an intersection. And what is infinite solutions? Well, that is when they are the same line. When both equations are the same line. All right, well, you have now learned all about graphing systems of equations, solving systems of equations by graphing. You graph each, you find their intercept, and then you observe the coordinate where they intersect. That is an x and y value, that is the solution, and then you check it. And now we've just learned that if you plot both graphs and they are parallel, if they have the same slope but different y-intercepts, they are parallel lines and there will be no solutions. And further, if they are in fact the same lines, so the same slope, the same y-intercept, then they are infinite solutions because they are the same line on and to forever. All right, guys, good work. We'll see you in the next video.